Welcome to a new test and teardown video. This time we are back with the oscilloscopes, a Trio CS-1830. So it's a 30 megahertz, 2 channels. I cleaned it up a little bit, some wet paper, because it was a little bit sticky all over from all those many years of use. I think I put everything here in a pretty good DC dual, because we want to see 2 lines, right? So that will be normal, single, where is, say, pull, auto tricking. So that's what we want. Trick mode. Ooh, we can have different lines of frames. What is fix? What are we fixing here? Focus. I just put. So this is the position. All right, and that will be the on-off switch. So let's look at the back and see if we got the right mains voltage. And here you can see the color is a little bit yellow too gross. And this is how it looked before I cleaned it. This kind of color all over the place. But of course, this one is from 1980. So this is quite old. So that will be the mains voltage selector. What have we? It's a little bit heavy, 9.5 kilo. Yeah, I think it is pointing to 220. And what I really like is this one got an IEC mains connector. So that is fantastic. I like that, instead of having a cord that's always too long or too short or whatever, right? And this is, of course, for the mains cable. So you could plug it in and then wind the cable, and then you're ready to rock and roll. So we are ready. I put in a cable and adjusted the voltage for 220. We got light. So that will be something to do with the trigger, right? That is not good. It's 30 watts. Is it out of the... Yes, I got a picture. Unfortunately, I already found a problem with this scope. So we got a very good reason to open it and fix it. See, now we are in mode, channel 1, and I can move the channel 1 all the way up and down. Perfectly fine, right? So let's go to channel 2, and that will be channel 2. And then I move channel 2 up and down, and it is only moving in the positive half and not even all the way up. So there's definitely something on the channel 2 before it goes to the chopper or alternator or to the amplifiers and all that. So in the low level stuff, there is definitely a DC problem. So that is something I need to look at. But now we have already figured out where to look. So why I didn't have a picture on before, that was because of this stupid mistake. So there's a single mode and there's a normal mode. Obviously, if you put it in single mode, you only get one shot at it, right? So normal mode, and in auto triggering. So every time I move past the DC level, here this is normal triggering, and now it's just re-triggering all the time, right? So we got variable hold off, and that also works. You can see the more hold off, it takes more time before it starts again. So all that seems to be working for us. So that will be the trigger source. I didn't even play with the triggers and stuff like that. But there's actually one more thing that I saw. So in dual mode, look at that. Channel 1 is down here, right? Channel 2 is up there. Let's go dual. And in dual mode, this is alternating mode. It's easier to see if we go real slow, right? One channel, the other one. One channel, the other one, right? So let's go a little bit faster. So in alternating mode, it looks a little bit like this. And see that what happens here with channel 2, it looks pretty nice, right? But there's a button here. If I pull this one, it goes in chop mode. So that means every trick, it draws both of the channels at the same time, more or less. It switches really, really fast. It chops up the analog signal. And that has an error. Look at that. And look, when I pull up and down on channel 2, it looks more or less funny with the chopping. So now I already know where to look for the problem with this channel. That is definitely the chop system. Isn't that just nice? Just from playing around with the front panel, I can see what is going on with this. And see, channel 1 works perfectly fine in chop mode, and nothing is bad with that one. And if we go real fast in chop mode, then we can also see, here we can see a little bit what's going on. Yes. So now I need to open it and have a look. Channel 2 all the way to the chop. Let's look a little bit inside. I start at the bottom first. I took off both of the chassis away. It's actually a two-part thing, so you can open it at the top or at the bottom. So this is the bottom board, and as you can see, input A is a little bit smaller and a little bit simpler, and input B is a little bit more complex, and that is because this contains also the chop stuff. That will be around here. This is as far as I guess, and this is the high voltage supply, and all that works, so we are not going to play around with all that stuff. So that will be some compensation capacitors for the different ranges, so you can speed up exactly as much as you need. We see a little bit of text here with the information about where we are on the schematic, so that is pretty good. It's a little bit yellow, this one. Pooey, as you can see. I don't know if it is visible on the camera the way that I can see this, but it is pretty yellow. So that will be all the time-based triggering stuff. That little shielded box here is the delay time. So this contains an extra oscillator. So this is of course why it is inside its own little case. So it's not going to affect anything here because it will be visible if there is anything that radiate or coupled to anything, especially if it's running at another frequency, right? And that was the high voltage step up supply that will be in there. And this is the horizontal deflection amplifier. with all the good stuff. So this one needs to be really fast. And yes, see something really funny here. Can you see there's a delay here? So this is of course when to delay the trace after a trick, so you're not going to lose the picture, or you're actually going to be able to display the start of the curve because it's delayed. So it still exists in kind of memory here, right? And then when the horizontal sweep is started, then you'll still have your curve going through this cable. And I don't know if this is visible, but you can see the two wires here. They actually go backwards and forwards in a special bifilar kind of winding system, and then it is of course shielded. I don't know. There's probably a good meter or something here. But all this works, so we don't need to worry about all that. And all the other deflection here and all that kind of stuff, of course, that also works. What we need to look at is that PCB down here. And the bug is probably around some of those ICs here, or the transistors and stuff. I was able to find a schematic, but it is in a sad low quality, like almost impossible to read. So that is not so good. I don't know if this is kind of lock or unlock really. I was looking forward to a really long and funny video about finding the error and fixing it and all that stuff, because it is really fun to find errors in old oscilloscopes. But kind of the fault was actually in the switches here, or in this one, the bad connections. So all I had to do was input a signal. Of course it was a little bit too much or too little, so I dialed those switches a little bit, and look at that. Now the problem is gone. This is channel 2. Hopper. And it works all the way up and down. And if I do the same with channel 1, you'll see what happens if I move channel 1. Ooh, that is because I'm triggering on channel 1. So if I move my trigger to channel 2 and dial in trick for channel 2, then I can move channel 1 up and down like I want to. And see, the level matches perfectly fine on the 2 channels. So I mean, that was a boring video because it's already solved. Yeah, I'm sorry about that, but okay, I almost forgot my classic speed test. So this is 1 kilohertz on channel 2, and I'm in 50 ohm mode here because of course old scopes like this, they don't have a 50 ohm internally, so you of course have to do it here. Then I know the level here is correct no matter what I do, right? So let's dial up. I adjusted 1 kilohertz to be like that, and then we can just crank up the frequencies. So that's 10 kilohertz. So that is a 100 kilohertz. Ooh, this one also needs a little bit of massage. So that was 100 kilohertz. See, the picture is exactly the same. 500. So that's 1 megahertz. Okay. I need to massage this a little bit, but still pretty good picture. And look at the brightness. I can just crank this up. I can really adjust the picture. This is a beautiful, beautiful picture with tons of brightness. I'm really impressed. So this is 1 megahertz, and of course it's still okay. That was 10. So yeah, I think I saw a little bit here. Have we got any more? Nope. We are in the fastest of the fastest. 10, 20. Ooh, what is that? 22, and then the trigger needs a little bit of fine tuning. 22, 25, 28, 30, yay! And that is about minus 3 dB, you're right. So I think there should be some dots around here somewhere. I think we are a little bit below them, okay? So, I mean, it's a little bit under 30 megahertz. So let's see how fast can this actually trigger. We are so close to the limit. So that is a 42 megahertz. Yeah, 43, 44, 45 megahertz. And let's pull. No, that is not. Yes, it is. Of course we can do that. Great. Yes, indeed. And let's see. And intensity. This is a 45 megahertz signal. All right, so I'm pretty happy about that. So this is actually what I wanted to show you with the delay line we saw in the amplifier. So now I've got a tiny little pulse. It's actually only 1 microsecond width, and I'm triggering on that pulse, of course. So let's just try and dial in the pulse. Look at that. I can see even the start of the pulse. And that is because this super nice delay line. So I trigger on it and start the time base, and I still have the start of my signal. It's really nice and beautiful. Let's see. This is the time base, 0.2. See? 1 microsecond. It is just so nice and accurate. I really like this old scope. It's 42 years old. Would you believe it? Now I'm playing a little bit with the delay trick here. This is, of course, I'm pushing this a little bit to the limit, right? And also this pot here needs a little bit of exercise. But look at that. I can play around with the delay from a trick to the next one, right? Isn't that just cute? This is the same signal, of course, right? You just thought we were done with the video, but no, we're not. And you maybe also think, hey, this is the same scope. And no, it is not. This is another one. Exactly the same model, CS-1830. But it is not the same scope. It is another one. Okay? Trust me on that. And here is exactly the same pulse. And I tried channel A and channel B, and I tried poking around all the triggering and everything. But I can't see the front of the pulse. Why can't I see that pulse? That is because this scope exists in different versions. And this is the version without the delay line. Look at that. Okay, let's turn it off. The delay line was supposed to be in here, but it is not. Isn't that just funny? This model, it is not mounted. the two yellow wires here, that is actually the input and the output where the delay line should have been, right? You just saw where it was, wind it up here, a whole meter of delay line, right? So that is something I did not know. And this one looks a little bit more nice and clean. It's not yellow anywhere, and there's no smell or anything, so it looks really nice and clean. It's still the same age, and it's still doing the same. When I dial a little bit around with the pods, I get a little bit of vibrations on the screen and stuff, but the more I poke with stuff, the more and more nice and stable everything gets. So it just needs a little bit of use, and then it's going to be nice and happy again. And let's look at the rear. They look exactly identical, but see that one? That is the D for delay line you need to find if you're, of course, going for this option. So that is probably a more expensive version of this scope, and you can't see it on the front at all.